So I'm giving you an example where we are having the path of the along the path of the curve, the particle is moving with certain acceleration, and we want to find the path. So here we are having the acceleration given, and as I mentioned it, that we integrate, we get the velocity, and then we integrate, we get the position vector giving the path, the vector value function. So there we need the initial conditions. So we are given the initial velocity also, and we are given the initial position of the vector. So with the help of these, we are able to find the constants of integration, and then we can get the vector value function. So let us see here the acceleration is given by a of t. As mentioned here, we are having a of t is minus 2 cosine t I minus 2 sine t j plus 2 t k. So I want to find the velocity vector v of t. Velocity is integration of the acceleration vector. So we just integrate this one, get minus 2 cosine t I minus 2 sine t j plus 2 t k and into dt. So 2 t k into dt. So here I just integrate it. We must know the formula for integration. As I mentioned to you before, we must know exactly integral of cosine t is sine t. So we get minus 2 sine t plus we are having here c1 into I. Then we are having minus 2 sine t. Integral of sine t is minus cosine t. So minus minus become plus. I get here 2 cosine t plus c2 j, and then the integral of 2t, we use the power rule. We are having t square by 2, 2 is considered 2. We get here t square plus c3 k. So here we want to find the value of c1, c2, c3. We are having given the value of the velocity vector, initial vector in t equal to 0, at t equal to 0, we have v0 is equal to 2j. That's we can write here is equal to 0i plus 2j plus 0k. Now the velocity vector I have just found, that is, we take the value of this one, we at 0, sine 0 is equal to 0, so we get here this is equal to c1i, then we have plus cosine 0 is equal to 1, we get here 2 plus c2j, and then we are having here t equal to 0, c3k. So we compare these two, they are equal. We are having here this vector 0i plus 2j plus 0k is equal to c1i plus 2 plus c2j plus c3k. Comparing the coefficients, we get the value of c1 is equal to 0, and c2 plus 2 is equal to 2, and c3 is equal to 0, and this gives me c2 equal to 0. So I have Vt, substituting the value of c1, c2, c3 in our equation, we get here minus 2 sine t I plus 2 cosine t j plus t square k. So that's my velocity vector. Now I can find the position vector. To find the position vector, I again integrate this one. So my r of t is integral of v of t dt is equal to integral of minus 2 sine t I plus 2 cosine t j plus t square k into dt. Now as before, we integrate again, and we can find here this equal to, so get here 2 cosine t plus c4 I. Then integral of cosine t is sine t, 2 sine t plus c5 j. Then we have t cube by 3 plus c6 k. So this is, and we are having here integration constant c4, c5, c6. We are given here in the information in the question that it starts from the point 2, 0, 0. It starts from the point we say that's the initial value of r of t starting at the point. So we say r0 is our vector, or r0 at t equal to 0 is the vector 2, 0 and 0 is the position vector, and we get the component of the point as a vector. So I have here the r of t when t equal to 0. Let's say t equal to 0. What's my r of 0? Substituting the value here, cosine 0 is 1. We get 2 plus c4 I. Sine 0 is equal to 0. We have c5j. t0 we get is c6k. So compare it. We are having here the vector as we are having 2 plus c4. We have c5, c6, and the vector we are having on the given vector, the initial condition, and the initial conditions are 2, 0, 0. Comparing the coefficients, we get here 2 plus c4. c4 is equal to 2. This implies c4 equal to 0, and c5 is equal to 0, and c6 equal to 0. We substitute these values in our equation and we get here r of t, the position vector of is equal to 2 cosine t I plus 2 sine t j and plus t cube over 3 k. So this is how we can find the position vector. This give me the curve along which the path of the curve. This is the path of the curve is required path of the curve. That's how we can find from the acceleration, given acceleration, we can find the path of the curve. So I'm going to give you another example. We want to find r of t. We're given a of t. The acceleration is I plus 2t j plus 3t k, and we are given the initial condition. Initial start r0 is I plus j plus k at the point 1, 1, 1, and the initial velocity is 0. Is moving from the 0 velocity. So we want to find this value of r of t. So we know our v of t. V of t is the integration of our a of t. So we just take here v of t, the velocity, is equal to integral of a of t dt. Now what's my a of t? A of t is I plus 2tj plus 3t square k into dt. So I integrate this one and write the constant separately. So get here ti, because coefficient of t is 1. Get 2t square over 2, 2 is cancelled with 2, we get here t square j. 3t cube by 3, 3 is cancelled with 3, 3 cube k. So we get here c1i, the constant in the direction of x-axis, c2j and c3k. Now we take our initial conditions. Our initial conditions given for the velocity, that v0 is equal to 0, 0 and 0, 0 vector. So I can write here v0 when my given values of this one, by putting t equal to 0. So my v0 is also equal to c1i plus c2j plus c3k, or in the component form we can write here c1, c2, c3, and we compare these two vectors and we can see the values we are getting for our constant c1 to c3, comparing these two. So we get here c1, and here is initial conditions given to us, and get c1 equal to 0, c2 equal to 0, and c3 is equal to 0. Substitute these values, I get here my value of the v of t. The velocity vector is equal to ti plus t square j plus we are having t cube k. So this is one part. The second part is I want to find r of t, and then my r of t is integral of v of t into dt. So I am having here ti plus t square j plus t cube k into dt. So I integrate this one and I will get here this equal to, again we have t square by 2, integration of 2 I into t square will be t cube by 3 j plus t 4 by 4 k plus constant integration along x-axis I is c4i, c5j and c6k. Now we have the initial given initial position, initial condition or initial position we say given for r of t and t equal to 0. Our initial condition at t equal to 0 r0 is given to me, and that was here given to me was I plus j plus k. Here is equal to I plus j plus k. When we take here r equal to 0 here, then I'll get here the value of t square is 0 at t equal to 0 is 0. So get here c4i, c5j and c6k, and then we compare these two vectors. They are equal, both are c equal to 6 0, and we compare this one, we get c4 equal to 1, c5 is equal to 1 and c6 equal to 1. We substitute these values in r of t. So our r of t, the final result will be equal to, putting value we get here t square by 2 plus 1 I plus t cube over 3 plus 1 j. We are substituting the values here, the values in my r of t. c6 is equal to 1. So we put value of c6, that is equal to t4 by 4 plus 1 into k, and that's our result of r of t.